Sometimes when redox reactions occur in an aqueous medium, they will require hydrogen and oxygen atoms from water molecules to occur. So they must involve water molecules, protons, or hydroxide ions as reactants or products. We need to be able to balance redox reactions in such a way so as to demonstrate the involvement of these ions. These have a slightly different approach depending on whether in acidic or basic conditions. But let's take a look at acidic conditions specifically. The dichromate ion will react with iron 2 to yield chromium 3 and iron 3. How do we balance this? The first step is to split this up into half reactions. For the oxidation half reaction, iron 2 becomes iron 3. For the reduction, dichromate becomes chromium 3. Now we must balance each one starting with elements other than hydrogen or oxygen. We can see that for the reduction we need to put a 2 here to have 2 chromium atoms on each side. Next, we balance oxygen by adding water molecules. We have 7 oxygen atoms on the left, so we need to add 7 water molecules to the right, since there is 1 oxygen per molecule. Now we can balance hydrogen atoms by adding hydrogen ions. Since there are 14 hydrogen atoms on the right from the 7 water molecules, we will need 14 hydrogen ions on the left. Now we can balance the electrical charge by adding electrons. In the oxidation, in order for iron 2 to become iron 3, it must lose an electron. So there must be 1 electron as a product here. For the reduction, it's a little trickier. We have 2 minus on the dichromate and 14 H pluses for a total of 12 plus on the left. On the right, we have 2 chromium 3 ions for a total of 6 plus. In order to balance this, we will need 6 electrons on the left to bring the charge down to 6 plus. Now we will need to combine these in such a way so as to cancel out the electrons. That means we will have to multiply this reaction by 6 in order to get 6 electrons to match the other half reaction. So 6 of each iron ion and the 6 electrons we need. Now we can finally combine these half reactions. Once they are combined, we can cancel out any species that appear on both sides, which in this case is just the electrons. So we can now see the exact number of ions that must react in order to produce this particular redox reaction.